Group aim. Our group aim is to determine what effect an inclined plane has on a projectile in motion. But individually, we are all analysing the data separately to determine different effects that the inclined plane has on the projectile.
So we're just in Bunnings picking out plywood. We've got this one, but it flexes too much, so it's not suitable for our experiment. This one, it's too light and flimsy, not robust enough. But this one is 18 millimeters thick and treated, so that's suitable for our experiment and it won't add any variables. We've just measured where our holes are going to be, so we're going to drill one hole there, and then we're going to run a fishing line through it. And the fishing line, it's going to be a loop that comes up here, and in that loop the car jack is going to sit. That's 0 degrees there, and we've realised that the jack maxes out with pulling the string, so okay, so that's where the jack is maxed out. That's at its maximum height right there, and as you can see with the string connected, it's only at 6 degrees. So we can do our 5 degree increment with the jack on the string, and we can do our 0 degree increment with the jack on the string, and then we'll just be taking the string off and sliding the jack under the ramp, and then we'll be jacking it up from there all the way up until 55 degrees. Now this plank of wood is 1200 millimeters, so that will be a good reference point on the tracker. So we're just putting a bowl on to weigh the ball. We're going to tear it to 0 grams. Perfect.
So basically, for our setup here, we're looking at projectile motion down an inclined plane. We have our board, and we know the length of this. So we're going to be, we've got that, and we're going to be able to prove our angle with our trigonometry. We have our inclinometer here, which is going to tell us our angle, so we can work it out as we're going along. And then every single time we're adjusting that angle, we're going to set this here and make it the level. And then we're going to set this up on top, drop it from that height, and then it's going to be able to fall, and then we'll be able to measure that. We're also going to be filming it from just here, but we've got our camera set up there, and then when we film it, we're going to press it, let it sit, and then we'll conduct the experiment so that it is stable and isn't adjusted by movement from us. Variables. The controlled variable in our experiment is the height that the ball is dropped from onto the surface. The independent variable is the angle of inclination of the surface that the ball is dropped onto. The dependent variable is the velocity. This is affected by the changing angle of inclination because when the projectile hits the surface of the board, the angle of incidence will change the velocity the projectile leaves the surface at.
We decided to use a car jack while conducting the experiment to eliminate having to use non-consistent angle increments. With a jack, we could increase and decrease the angle at very small increments with ease. We used a lot of white light while conducting the experiment to ensure that we could track the projectile in motion easily. The white light increased the already existing contrast between the blue ball and the white wall. This also allowed the program tracker to recognize the subject, the ball, easier. The choice to use a rubber ball comes down to the fact that rubber on wood has a high coefficient of friction. This means we could eliminate any risk of slipping or sliding when the ball contacted the wooden inclined surface. We used 240 frames per second, which meant we could analyze the video with much more accuracy. Having a higher frame rate in the program tracker is favourable because we have much smaller increments to look at.
Distribution of work. When the experiment was being conducted, Felix was filming the experiment. Sam and Josh changed the angle of inclination of the surface the ball drops onto, and Sam dropped the ball. For the video, Josh edited the video and pieced together all the clips. All 3 members of the group have voiceovers for the video and all contributed to the filming of the vlog on the day of the experiment.
For the tracking process, first the tracker app was opened, then the clip that needed to be tracked was imported into the app. Then the clip was cut to the section where the ball was dropped. The clip's frame rate was set, then a calibration stick was set to the length of the ramp, which was 1.2 meters. The axis was set to the point of contact on the ramp, and a new tracking point was created and an auto tracker was started. The data tool was opened and the data was able to be analyzed using the graphing functions of the tracker. Safety. To ensure safety in the experiment, we used safety goggles when drilling the holes in the board and made sure to keep a safe distance from the ball when it was being dropped. We also made sure to use a car jack in a safe and correct manner to make sure no one's finger or clothing got caught in it. Apart from these aspects of the experiment, it didn't have many risks while doing it because of the low speeds of the ball and the nature of the experiment.
We mitigated error in many ways while conducting the experiment. We used a car jack to adjust the angle. This made our angles were accurate. We concealed the room from the outside. This meant there were no unnecessary forces acting on the ball, like wind. We made sure our ramp was straight and trued up so each drop was consistent. However, there are a few errors that influence the accuracy of our experiment. The drop height may have varied for each test. This is because of human error. We held the rubber ball above the ramp by the same distance every time, but the distance may not be exact. As a result of using the rubber ball, it undergoes deformation as its velocity changes direction as it contacts the inclined plane. This uses energy. Parallax error is also throughout the experiment in many ways, including drop height, tracking, and calibration. All errors are looked at in depth on the individual reports.
In conclusion, our experiment was conducted safely and successfully with a range of angles to analyze. Thanks for watching.